Okay, let's continue with division of radical expressions and rationalizing denominators. Okay, so let's say if I wanted to take something like the square root of 5xy squared divided by the square root of 5x. Well, this is a fairly easy simplification. I can simplify this off. I can split off the square root of 5x and the square root of y squared, and I can split out, I have the square root of 5x here. The square roots of 5x, I multiply and divide by them. They just get to be canceled. I've got the square root of y squared. We don't know if y is positive or negative, so I end up with the absolute value of y. So sometimes we can just sort of cancel things right away. Another thing that we can do is we could rationalize a denominator. Say I have, say 5 over the square root of 7. Historically, people didn't really like dividing by irrational numbers. If you divide by 2, people sort of understood, well, you're going to split things in half. And if you're going to divide by a fraction, we figured out, okay, it makes sense to flip and multiply. But if I'm going to try and divide by something that has no end as a decimal, right? Like the square root of 2 is 1.414 dot 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 dot, or pi is 3.1415 dot 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 dot. Well, how do I divide by something that doesn't end? That got people a little worried, so we decided to rationalize denominators. Well, rationalizing denominators is as simple as multiplying the top and the bottom by 1 again, but the 1 is going to be specifically chosen so that the denominator is no longer a square root or a radical. So if I multiply the bottom by the square root of 7 again, the square root of 7 times the square root of 7 is 7, but I don't want to change anything, so I have to multiply the top by the square root of 7 as well, and I end up with 5 square roots of 7 divided by 7. And historically, people were happier with 5/7 of the square root of 7 rather than trying to divide by this decimal that never ended. So that's the idea of rationalizing denominators. Let's see another one that has some algebra in it. Maybe say we've got 5 and I've got the cube root of 6n squared. And I want to rationalize this denominator. So this is a cube root. To get rid of that radical, I would need 3 copies of the 6n squared under the cube root again. So let's put down the other 2 copies, which I'm going to write as the cube root of 6n squared, and I'm going to write it as squared. And here I've got the cube root of 6n squared squared. Okay, that's the properly chosen one so that the denominator is no longer irrational. I've got 5. I've got the cube root of 6n squared squared on top, and I've got, well, I got rid of that radical by multiplying 3 cube roots together, so I should have 6n squared on the bottom. And there we've simplified that one. Okay. Some people might not like that I'm squaring something that's already inside of a cube root, so we can put that squared inside. I could also write this as 5 times the cube root of 36 into the 4th, right? Squaring everything inside here, squaring 6 squared gives me 36, squaring n squared gives me 4, is also a nice way to write this. Either of those I think is acceptable. This is maybe slightly more simplified. Okay, let's see another example. What if I have an addition under the bar in the division? Maybe I have 1 plus the square root of 2 and I'm dividing it by 1 minus the square root of 2. Okay, that's still a irrational denominator. We would still run into the history people telling us, oh, I can't divide by that unending decimal. So somehow we have to get rid of this. This guy down here and turn it into a rational number. Well, one of the tricks that we've had from the past is a difference of squares, and we're going to exploit that now. If I multiply by 1 plus the square root of 2 on the bottom, I will end up with a difference of squares. Okay, and this is called the conjugate. These two guys, these are conjugate pairs. of radicals. Okay, and it gives me this difference of squares, right? So if I FOIL out the top and FOIL out the bottom, well, I'm just going to write it as 1 plus the square root of 2 squared on top for now. But the bottom, I've got the FOIL as the first guys, 1, plus the, the outside guys, so plus the square root of 2, plus the inside guys, so that's a minus the square root of 2, and plus the last guys, so that's a minus a square root of 2 times the square root of 2, right? And because this is a difference of squares, these two inside terms, the outside and the inside term, they're going to cancel. I'm going to be left with 1 plus the square root of 2 squared, and it's going to be divided by 1 minus, well, the 2 times the square root of 2 times the square root of 2 is 2. So this is equal to 1 plus the square root of 2 squared divided by minus 1. Okay, that division's fine now. So I've got dividing by minus 1 is the same thing as multiplying by minus 1. I'm going to do the FOILing on the top. So I've got the first terms, which are going to be 1s. I've got plus a square root of 2, the plus a square root of 2, and plus a square root of 2 times the square root of 2, right? So this is a minus 1 times 1 plus 2 square roots of 2 plus 2. So this is equal to a minus 1 times 3 plus 2 square roots of 2. So I've got minus 3 minus 2 square roots of 2. So we took a lot of steps to simplify, but we got rid of this irrational denominator by multiplying by the top and bottom with the conjugate. Let's see another one. Let's see something with some arithmetic or some algebra in it. Let's look at the square root of x minus 3 over the square root of x. Okay, if I don't want that radical in the denominator, this one is going to be the square root of x minus 3 over the square root of x times the square root of x over the square root of x. Multiplying the square root of x by the square root of x gets rid of the radical bit. Okay, and so now I end up with distributing this across the top. I get the square root of x times the square root of x is x minus 3 square roots of x, and I get to divide by x, right? So I've got rid of the radical in the denominator there. Okay. Let's see one more with some algebra in it. Let's go maybe the square root of x minus 2 over, say, the square root of x minus 1. Okay, if I want to get rid of this, I need to multiply by the conjugate pair, so I'm going to use a difference of squares again. In this case, I want to get rid of the denominator, so this denominator's conjugate is going to be a square root of x plus 1, right? If this is a difference, you get the sum. If it was a sum, you get a difference. So I have a difference here. This is a difference. This is going to be the sum. So I get the square root of x plus 1. Okay, let's FOIL these guys out. Square root of x times the square root of x is x. I've got a minus 2 square roots of x plus 1 square root of x, and I've got a minus 2 on the top from the FOILing. As a difference of squares, this is going to be an x minus 1, right? So if I practice my difference of squares, I take this thing squared minus this thing squared. So the square root of x squared is x. The square root of 1 squared is 1. So I get that as my difference of squares. I can combine like terms on the top. I've got x minus the square root of x minus 2. When I combine like terms on the top, and I've got this x minus 1 on the bottom. So that's rationalizing denominators. Sometimes we can rationalize numerators too. So maybe let's do one where I rationalize a numerator instead. Let's look at the same thing, the same exact problem, but we're going to rationalize the numerator. So I've got the square root of x minus 2 divided by the square root of x minus 1, right? So this was rationalize denominator. So I made the denominator not have any radicals in it. No radicals. Right. Now I want to make the numerator not have any radicals. So we're going to rationalize So we're going to make the top not have any radicals in it. So I'm still going to use the same idea that I'm going to multiply by this conjugate. The numerator's conjugate, I have a difference, so I will have a sum over here. So I'll have the square root of x plus 2 over here. And I'll divide by the square root of x plus 2, right? I don't want to actually change anything if I'm going to write equality down, so I need to multiply top and bottom by the same thing. Now I've got my difference of squares on the top, so I get x minus 4, right? There's the square of the first guy, the square of the second guy, and I've got the difference. That's the difference of squares. And then the denominator I get to FOIL out. I've got x, I've got minus the square root of x, I've got plus 2 square roots of x, and I've got minus 2. Now I can combine like terms on the denominator. I've got x minus 4 divided by x plus the square root of x minus 2. And now my numerator has no radicals. So I've rationalized the numerator in that case. The previous one we rationalized the denominator. Okay, that's how you rationalize denominators and do simplification of division of radical expressions. That's it for chapter 7. We'll see you guys in the next module.